Hey everybody, welcome to part 2 of this tutorial series on geometry prep for a structural simulation. In this video, we're going to be focusing on repairing this geometry, doing some defeaturing, and basically cleaning it up to transfer to mechanical. So you may see that there are two bodies, specifically this arm and this arm, that are transparent. So they came in as transparent into Discovery when we imported it, and that's basically Discovery's way of saying that they have come in as a surface body. Now, this can typically happen if there is some corruption in the translation when we import it and so on. So that's something to take care of, as we'd like it to be a solid body that meshes in our simulation down the road. To look at this more carefully, let's take a look at the geometry tree. Let me hide the bolts and nuts. And for our arms, let's expose the right arm and the left arm in the geometry tree. And we can see that the right arm has multiple surfaces and the left arm has a single surface. Now let's see how we can repair this using some of the tools in Discovery. Now to access the repair tools, click on the repair tab in the ribbon here. And now we can see that we have different tools to solidify, fix, and adjust different aspects of our geometry. To begin with, let's look at the right arm. So we have multiple different surfaces, so perhaps we'd like to combine them into one. One super helpful option is the stitch option right here. This will allow us to combine different surface bodies together. So if I hover over this red area, we'll be able to see the exact boundary that we can stitch together. We can also change the maximum distance, which is essentially a tolerance that we can toggle from. Now that we have identified this area, we can click the check mark, and this will allow us to fix that. And as you can see, we have a opaque body now, basically signifying that we have a solid body. And we can also see this here, since the right arm is now a solid. Okay, so we still have one more body that's still a surface, this left arm here. So let's look at the other tools that we can use. So let's check out gaps. So when we click on gaps, we see that the green check mark is not valid. This means that we don't have any gaps in the model. We can also see this more explicitly in this bar over here, which says no areas found. What we can also try out is missing faces. So when we click on missing faces, we do indeed see something pop up. Now, if we'd like to take a look at the exact areas where these missing faces exist, we can obviously hover over this area and see the red boundary, but we can also click this option, which might be useful in some cases, which is zoom to fit. And that actually zooms into the particular areas where we're missing a face. Okay, so now let's fix this missing face by just clicking the check mark, and we'll be able to see that we have a solid body now. And this was the basics of the solidifying tools in the repair tab in Discovery. And basically it helps you solve the issues of importing any surface bodies, or if there's any corrupted faces, you can use these tools to fix that. Okay, so let's exit out of the missing faces tool by pressing escape twice. And then let's look at two other tools that can really help us with any meshing issues down the road. So one of them is extra edges. This will detect and remove any extra edges that doesn't really define the shape of the model, but will really help preventing any meshing issues later. So let's click on the check mark and remove these extra edges. The next option that I want to talk about is actually under the Measure tab. So click on Measure and then exit out of the Extra Edges tools. This time we'll have to select the geometry that we want to work with. So let me create a box around the model to select all the bodies and then click on Check Geometry. Now, check geometry is a really nice way to predict any issues that are inherently in the model that might not seem so obvious. So for example, for every body, there are associated issues, and you can click on the zoom to fit to see the particular body that we're talking about. So this body has some issues, certain other bodies also have some issues, and we can see this, specifically what's going on with that zoom to fit option. Now, in this case, much of these issues aren't really pertinent, so we're not going to do anything about them. But this is a nice thing to always do, right? Check your geometry to ensure that you don't have any particularly problematic areas that that might cause meshing issues later on. So let's close this out and let's look at the repair tools again. Okay, so the last thing that I wanted to mention about is these fixed curves and adjust tools. Now, for the fixed curves tools, they're primarily used for 2D models, sketches, drawings, and so on. So they aren't particularly useful in this case. With respect to adjust, these are some of the more advanced level tools, again, that are not relevant in this case. But just a warning that with respect to the adjust tools, the changes that you make are generally more permanent in nature. So it's going to be difficult to undo any of the changes that you make with those tools. So something to keep in mind that be 100% sure what you're doing before you actually go in and make those changes. Okay, now that we've looked at some of the repair tools, let's switch gears and look into how we can do some defeaturing or geometry cleanup. Now to do this, let's go to the Prepare tab in the ribbon. And here we can see a bunch of different ways in which we can actually defeature this model. Okay, so to begin with, let's focus our attention on the remove tools. Click on rounds, and with this tool, we can basically remove some rounds in the model. So we can click on these faces and then click the check mark, and that will remove those rounds there. The other thing that we can do is click on this faces options. So this will fill in any faces or it will extend any neighboring faces. So what we can do is click on these faces here by double clicking to select the entire boundary here, and then click on the check mark and that will fill in that area. Now, the other option to do this is actually using our fill tool, which is found on our design tab. But the other way of getting there is we can click on the hex here to open the halo, and we can click our fill tool and then do something similar. So we can select those areas and click on the check mark, and that will also fill it. So here are two ways in which we can defeature certain gaps, certain rounds, and so on using our remove tools or our fill tool. Okay, so the next important thing to make sure is that we don't have any interference in our model. So to check whether there is any interference or not, click on this interference tool. Now we can see the areas that are interfering in red pop up on our screen. And let's talk about how we can go ahead and solve this issue. So one of the ways is to just click on this green check mark and that would remove the interference. However, we need to be slightly careful about that because it's essentially going to subtract that interference regions from one of the bodies. Now that may or may not be something that we're okay doing, but in this case, let's also look at a more manual option. So exit out of the interference tool, and to get a better sense of what we're dealing with, hover over this bolt here, click on that axis, and click on your keyboard option X, which will put us in cross-section mode, and then we can look at this more carefully. So we can see that we have interference in this section, and then this section. Now, to remove this interference, what we need to do is basically move this area out and upwards away from the bolt. So there's one of two ways in which we can do this. We can simply click and drag this edge, but this is a little bit more of a guess and check way because we don't know exactly where it has lined up. But what we can do is instead, we can click on that edge, go to our pull tool from our halo here and click on pull. And then let's select the command up to and select the edge of this bolt. This way, in all those four regions, we're moving that area up to the region of the bolt so that there is no interference. Likewise, let's select this edge, click on up to, and click it up to the bolt. And this should remove the interference. Let's exit out of the tool, press D to go back into 3D mode, and let's look at if we have any interference. And now when we click on that interference tool, we see that we have no areas. So again, no areas found, and we have basically taken care of that interference. Okay, so the next thing that we'll take a look at is how do we align this back bolt here. So let me exit out of the interference tool and we'll be able to see that there's a bit of a gap here. So if we'd like to, position that bolt more appropriately, let's go ahead and do that. Triple click the bolt to select the body and then select the move tool from our halo here. So select move. And then what we need to do is we need to move the anchor, which can be found using this sphere right here, and move it all the way to this face so that it is aligned to that face. And then let's click on the move up to command and select this face. And as you can see, this moved it, parallel to that face, and we have proper alignment. Okay, so the last thing that we're going to take a look at is how to split up this bolt right here such that it's easier to apply a certain boundary condition in our simulation. So to do this, we might want to split it at this edge right here and then this edge right here. To do this, click on Split by Plane and then select the target body and then select this edge as the cutter face. And then select the target again. So in this case, it would be this half of the body now. Select the cutter and then select this edge again. And this way we have split up our bolt into 3 parts, and it will be much easier to apply a certain load in our simulation using just this face here. So that's all for part 2, where we learned about repairing, cleaning up, and defeaturing geometry for structural simulation. Please watch part 3 now, where we will talk about doing shared topology, name selections, and transferring to Ansys Workbench. Hope this was interesting, and thank you for your time.